if the event takes place, well, the handler will take over, and if the event doesn't occur, well, the handler will never be activated, so the program will just run as it's supposed to do. So if you have a Control-C catcher in your program, well, then your program will run, and if there is never given a Control-C from the keyboard, your program will run without handling the Control-C. But if somebody presses the Control-C, well, your Control-C handler will react to that, print the message or whatever. Okay? Pleased? Okay, enough to talk about at the examination. Pick any of the three which you like the best.
When you ask what is an exception, isn't that just a kind of a signal?
Yeah, it is. So an exception is active. Yeah, what is an exception? Could you give me an example of an exception?
Divide by 0?
Yeah, that's a very good exception, or a very bad exception. But it's a good example of an exception. If you divide by 0, that will actually, on any computer nowadays, that will be seen as an error. What will happen?
The kernel will signal difference.
Yeah. Actually, the kernel do not know about dividing by 0. But you have a piece of hardware doing the division. And when that piece of hardware detects that we're dividing by 0, it will raise an exception. If you have a handler for that exception, it will be caught by your program. And then you can write a message on the screen saying you entered illegal data. But if you haven't got a handler, and we know that the divide hardware will generate an exception or an interrupt, what will happen then if you haven't got a handler?
Crash?
Yeah, the program will abort because the signal will be sent to the kernel. The kernel, for those signals which will occur, we know if there are errors in the program, those exceptions will occur, and if you do not have handlers for those exceptions, they are sent to the kernel, and the kernel will abort the program at once.
I don't understand, do we have separate signal handlers and separate exception handlers? Or, when I do the program, or are they the same? Because
Well, if you print the list of signals, you will see that floating point errors, divide by 0 errors, and so on, they are all defined as signals which can occur. And if you don't want your program to crash, if it makes a mistake like that, you have to define the handler. So you get the message, I have a program which ran into a divide by 0 error. What will I do about that? If you haven't got the handler, the kernel will get the signal, and the kernel knows only of one thing: when a program is making an error, crash it, abort it. Just like you have also seen this. I think SIG fault or something like that, SIG error or SIG V error or something like that. You ran an exercise actually printing the environment of a program where the index ran over out of the environment table, and you got a SIG fault error actually. If your program doesn't handle that, it aborts with an error message. And if you don't want your program to abort because your array ran over or something like that, then you have to handle it. Then you have to handle that exception yourself. So exceptions and signals, exceptions are signaled by signals, and if you haven't got a signal handler in your program, a default signal handler will take over, and that is always defined by the kernel, and the kernel will crash the program. Okay. Which is not good, because if your program is used by a user which is not, doesn't know a lot about computers, he will think, okay, I made a terrible mistake. I used the keyboard in the wrong way because the program crashed or something like that. He doesn't think that you make an error writing the program. You know, when you see things like that, okay, the guy programming this program is, well, he's a dummy. He don't know what he's doing. So never let your program crash if you can avoid it. All errors in a program should be dealt with by the program, and giving the user sensible messages saying, okay, we experienced an error here and we cannot continue. We are sorry. Not your mistake. It's an unexpected error in my program. The next version will repair it, or something like that. Give the user a message with it, so he can see that he did not do anything wrong. Right? But exception handling is some of the harder things in programs, because if you should have tried catch for all possible exceptions, you know that your program becomes quite big. You should have exception handling for all possible exceptions. Yeah. But your turn. Okay. That was a long way to go. What about, should we have a break now? Or ready to continue?
A short break.
A short break. We take a short break, and then we'll talk a little bit about the shell. Yeah. Yes, let's have a short break.
It's 10, but we get about 10 minutes to get about.